this video, we are discussing the Intext questions 3.6 in the chapter Electrochemistry. The cell in which the following reaction occurs, 2Fe3 plus 2I minus gives rise to 2Fe2 plus I2, as an E naught cell is 0.236 volts at 298 Kelvin. We need to calculate the standard Gibbs energy and we need to calculate the equilibrium constant. So we will be using the various relations between the Gibbs free energy and the E naught cell. So first of all, let's write down what's been given to us. So we've been given that E naught cell equals to 0.236 volts. Okay, now I also know that it might be a little difficult for you to figure out the number of electrons. So let's break down this particular reaction. So the oxidation and reduction halves would be, so here Fe is undergoing, what is it undergoing? It is, I minus is undergoing reduction. No, it's undergoing oxidation actually. Oh, that makes sense. Okay, so I minus is undergoing oxidation and Fe is undergoing reduction. So you have 2Fe3 plus how many electrons gives rise to 2Fe2 plus, because it's gaining 2 electrons, we have just it throughout. And then I minus is actually, I just realized that I minus was underneath Fe in the electrochemical series. So it'll undergo oxidation. So 2I minus gives rise to I2 plus 2 electrons. So the number of electrons taking part in this particular reaction is equal to 2. So N will be equal to 2. Now, what we'll be doing is we'll be using the relation between delta G, that is the Gibbs energy, and E naught cell. So delta G naught is equal to NF E naught cell. Okay, now the value of F is equal to, I know it's equal to 96487 coulombs per mole, but we can just say 96500 coulombs per mole. Okay, so we're just going to be substituting all of these values. So this will give us 2 into 96500 coulombs per mole into 0.236 volts. First of all, coulomb volt equals to 1 joule. That is something we also discussed. That was the case even for one of the example problems right after Gibbs free energy. So basically joule is the unit of energy and the work is the work required to move an electric charge of 1 coulomb through an electric potential difference of 1 volt is 1 joule. So we are just using that. So CV equals to 1 joule. So this is equal to minus 2 into 22774 coulombs, joules per mole. Let's simplify this further. We get minus 45548 kilojoules per mole. Oh, okay. Joules per mole, and this is equal to minus 45.548 kilojoules per mole. So this is how we calculate the Gibbs free energy. And now we have a relation between the Gibbs free energy and the equilibrium constant. For that, we use the equation delta G naught equals to minus RT ln Kc. So Kc is the equilibrium constant, right? So actually, I'm just going to write the equations over here. So you will be just substituting these values. So I'm just going to use joules per mole. That's because the value of R equals to 8.314 joules per Kelvin per mole. Okay, so it's obviously, you know, encouraged to have them in the same units. So, and then you have the temperature given to us, which is at 298 Kelvin. So you have 298 Kelvin. Okay. 298 Kelvin. So we're just going to substitute all of these, and we are going to be using the value of it in joules per mole and not kilojoules, because you have the value of R at joules. So you can either do that or you can convert this to kilojoules. It's your wish. In the end, it's all going to get cancelled anyways. So you have minus 45548 joules per mole equals to minus R, which is 8.314 joules per Kelvin per mole, into 298 Kelvin into 2.303 into log of Kc, because you're converting ln to log. First, let's look at the units, because that's my favorite part. Joules and joules get cancelled. Negative sign and negative sign gets cancelled. Per mole gets per mole and per mole gets cancelled. Per Kelvin and Kelvin get cancelled. So you have no units because Kc is a constant. So you don't have any units for Kc, and that's fine. So 45548 equals to, let's start simplifying this. Basically 298 into 2.303 is 686.29 into 8.314 log Kc, and then 45548 equals to these two. When we multiply, we get 5705.8 into log Kc, and then we'll have to divide 45548 divided by 5705.8 equals to log Kc. So we get log Kc equals to 7.982. And then when we take anti-log on both sides, the value of Kc equals to 9.59 into 10 to the power 7. So all we did in this question was use the two equations provided to you in, like, when we talked about the, or I mean, let me know if you want a video, because I'm assuming I'll be posting this before I post the videos related to the topic. Let me know if you want the video on the Gibbs free energy. All we're doing in this question is substituting the values, I mean, using the formulae given under Gibbs free energy and substituting the values of the constant and the given and the E naught cell, and then we moved and found out the value of delta G. That's the Gibbs free standard Gibbs free energy, and then we were able to calculate the equilibrium constant. Well, that we're done with example in-text question 3.6. The next video I might actually start the in-text questions or the example problem in between.